Good evening. My topic for this evening is plane areas. We will derive by integration the formula for taking the area of a rectangle. We will derive the formula. We know from lower mathematics that the area of a rectangle is actually length times width. It is something like this. This is a rectangle. This should be the length, and this should be the width. And from lower mathematics, if we try to solve the area, we will try to multiply this width here times this length to cover up the total area. So by using integration this evening, we will derive the formula area equal to length times width. Actually, that formula emanates from integral calculus. Okay, let's proceed. So this is now lesson number 51 under my channel, topic integral calculus, plane area. The topic for the meantime is rectangle. We will derive the formula for taking the area of a rectangle. Okay, I will read the problem. It's just a formality. Derive by using integration the formula for taking the area of a rectangle with the length L. The length is L. And width W. Using two methods. Two methods meaning method number one will be by using a vertical slice. And method number two will be using a horizontal slice. The purpose of that one is that supposed to be the answer for method number one and method number two. What will come out should be the same. Okay, that's why, as a matter of educating you guys to solve for the problem using the vertical and horizontal slice, the answer should be the same. That's the relevance of the two methods. Okay, let's bring out method number one. Solution number one using vertical slice. The number one requirement is that we must have to figure out the rectangle on the Cartesian coordinate system. So we will draw the y-axis, we will draw the x-axis. They are perpendicular with respect to each other, meaning this is 90 degrees. It is always that the y-axis and the x-axis is perpendicular with respect to each other. So the required rectangle is this one. The one shaded by the red pen, that's the total area of the rectangle. Okay, we will try to place the designation of the four corner points of the rectangle on the Cartesian coordinate system. This is the length of the rectangle, and this is the width. Okay, so this point here should have coordinates L and 0. The upper one, the coordinate should still be L, but the height of that with respect to the x-axis will be W. So the upper one, the coordinates of the upper one should be L and W. Let's go to the left hand side. This is one of the corners of the rectangle. I place a designation to be at 0, 0, meaning it is at the origin. It is at the location x with respect to x, in location 0 also with respect to y, that's why it is 0, 0. 0, 0 is at the origin. Okay, the upper one, x is 0, and the y at this point here should be W, because the height of the rectangle is designated by W. You could place it H or W, it's the same. But in my designation, I place it as W. Because this is W and this is L. Because I want to bring out the formula for taking the area in terms of length and width. It depends on your designation. You could place it as x and y, but as a general formula, you should place it as simply length times width. Okay, let's proceed with the solution. Drawing a vertical slice, okay, the thickness will be dx, and the height will be y higher minus y lower. Y higher is the y higher should be the y over here, and y lower should be the y over here. So I place it here, y higher minus y lower. And we are just lucky for this rectangle here, because y lower, as it moves from 0 to L, it is actually constant. Why it's constant? It is a straight line. Even y higher, it's also a straight line. We are just lucky. For a rectangle, y lower and y higher is a straight line, and the equation of y higher is w. The equation, the ordinate at this point, this vertical strip, as it moves from this point here to this, it is actually constant, and the equation of that is y higher is equal to w. W is a pure constant, and actually if you try to analyze this one, this is a straight line. Y lower is the y of this point here. This differential strip moves from this point here up to this. As it moves, we could say that the y lower is actually not changing value, and the value of that one is y lower is equal to 0. And this is y lower is equal to 0 is also a straight line. Okay, so this is a straight line, and this is a straight line. And the equation of this is y higher is equal to w, and the equation of the lower one, y lower is equal to 0. Okay, so if we try to take the area now, differential area is y higher minus y lower times dx. It is this height here times the thickness. So differential area will be w minus 0 quantity times dx, or differential area is w times dx. Okay, let's bring out the limits. The variable on the right hand side is x. So meaning the value of x should move from 0 to L to cover up the total area of the rectangle. So actually XL is 0, XR is L. Okay, the initial 0 will be 0, and the final 0 will be equal to the length of the given rectangle. It is XR is equal to L. So if we try to integrate both sides, the integral of differential area equal to the integral from 0 to L of w dx. W is constant, we bring it out, so it will become the integral from 0 to L of dx. And what is the integral of dx? It is just x, okay, with the limit from 0 to L. Substituting limits, area now will be equal to w times the quantity. Upper limit will be L minus the value of the lower limit 0, and this is now 0. Okay. So what will come out for the formula and how to take the area of a rectangle? Area now will be simply length times w. W times L, or LW, it's the same. Okay. This could go ahead, or W could go ahead, it's the same. Anyway, the operation is multiplication. So actually, this is the general equation for taking the area of any rectangle. Okay. This is a rectangle. We are given the length, we are given the width. To take the total area, just use that formula. Okay. That's the formula we are using under lower mathematics in the computation of area of something like a lot, right? If you buy a piece of land, okay, And if that land is a regular figure like a rectangle, to compute for the total area, just multiply the length times width, and that will be the square units of the area of the land you are buying. That's solution number 1. Let's bring out solution number 2 using the horizontal slice. We bring out the same figure, okay? The same designation, this is L0, this is L in W, this is 0, 0, this is 0 in W, and we draw a horizontal slice. Why horizontal slice? Because to cover up the total area, this horizontal slice should move from 0 up to W. We move this one vertically up. And we are just lucky. Why? Because this side here and this side is constant. As the horizontal slide moves from 0 to W, this one is not changing and this one is not changing. So actually, to compute for the equation of this one and this one, it's an easy thing. They are both vertical lines, okay? So if we try to bring out the horizontal slice, the thickness will be dy, it is along the y-axis, right? And the length will be xr minus xl. xr minus xl. The length of the horizontal slice will be the x here minus the x here. Okay. As this horizontal strip moves from 0 to W, okay, there is an x for both the left and right. And we term the one on the right as XR, and we term the one on the left as XL. So this is XL over here, there is an XR over here. That's why the difference XR minus XL is actually the overall length. And we are just lucky. They are constant. They are not varying, okay? Taking the differential area will be XR minus XL times dy. Okay, what is XR? XR is the X of this vertical line over here. Okay? And the equation is XR is equal to L. This is a straight line. Constant. Why constant? Because for any given rectangle, L is constant. And the value of X on the left, as it moves from 0 to W, okay, XL is 0. This is also a straight line. And it is also constant. Okay? So for a rectangle, XR and XL, this is L, XR is L, XL is 0. It's not a complicated thing for a rectangle, but other figures, it's not the same as this one. Therefore, differential area, we'll go back to this. Differential area is L minus 0 times dy. Okay, let's try to bring out the limit now. Our thickness is dy, it's a vertical slice. So to cover up the area covered by the red pen, dy should move from 0 to W. So our lower limit will be 0, upper limit will be W. Okay, integrating both sides. The integral of the differential area equal to the integral from 0 to W. dy should move from 0 to W. This is W. Okay. The integral from 0 to W of L dy. L is constant, it will come out. The integral from 0 to W of dy. And what is the integral of dy? It is y. So this is L times the quantity y with the limit from 0 to W. Substituting the upper and lower limit, area now will be length times the quantity. First upper limit is W minus the value of the lower limit 0. But this is 0 already. So in general now, using solution number 2, area is length times width. It's the same. It's the same. That's the significance of the two solutions. what will come out on the answer should be the same. We are just presenting two solutions. Okay, guys? Actually, I will discuss a square over here because we are through with the square already. We are through with the equation for taking the area of a square. For a square, this is the side and this is the side. Actually, a square is a special case of a rectangle. For a square, the side is equal to L and the side is also equal to W. So if we try to follow the formula length times width, okay, for a square, the area for a square equal to length is equal to S. W is also equal to S. And what is S times S? It's equal to S squared. The emanation or the formula S squared actually emanates from the formula area equal to length times width. Because a square is a special case of a rectangle. Okay, that's it guys. Good evening, Los Angeles.